and solve multi-step equations. Please set your notes up so it has the goal at the top, a section for questions, and a part for conclusion at the bottom. The previous two lessons were solving one-step equations and solving two-step equations. This lesson is called multi-step, and what you're going to see is we're trying to get back to either a one-step or a two-step equation. We have to simplify the equations that are given so that we can backtrack. So our first example is 4 times parentheses 2x minus 7 equals 20. So we'll use the distributive property to distribute the multiply by 4. That becomes 8x minus 28 equals 20. When we get this far, now it's a two-step equation. Why couldn't we just put this into backtracking? Because of these parentheses. We don't know what occurred first. We don't know what occurred next. It's too complicated. Right here we know that a number was multiplied by 8 and then 28 was subtracted from it. It became 20. So we'll set that up with backtracking. There was a number. It was multiplied by 8. It became a new number. We don't know what that was. 28 was subtracted from it, and it became 20. So we'll backtrack and add 28 to get 48. 20 plus 28 is 48, and then we divide by 8, and x is equal to 6. You can skip to conclusion. Oh, there it is, sorry. To use backtracking, there must be only one variable and no parentheses. I'll back that up so you can see that again. Sorry about that. If you're doing this independently, I'm trying to get it so you can see it. Conclusion, to use backtracking, that should be a there instead of a the. There must be only one variable and no parentheses. So up here, we can't backtrack with these parentheses. We have to multiply out so that it's just a two-step equation. Okay, let's look at example 2. Minus 2x plus 9 equals 4x minus 15. Now we have an x on both sides. You can only have one x, one variable, in one place to do backtracking. So we're going to make what's called a zero pair. And whatever we do on one side of an equation, we have to do to the other side of the equation. zero pair can be crossed out, eliminated, and that's why we create it. So we're just going to put a line through the negative 2x plus 2x. That eliminates it. And we can just write what's left, which is 9 equals 6x minus 15. We added 4x plus 2x and got 6x. We now have the ability to backtrack. So there was a number, it was multiplied by 6. 15 was taken from it, and it became 9. So we do the opposite of subtracting 15. We add 15. 9 plus 15 is 24. And then we're going to do the opposite of multiply by 6. We're going to divide by 6. So x is equal to 4. The only way to backtrack is to have one variable and one operation. We can only do two-step backtracking. Last example. 5 times parentheses x plus 8 equals negative 2 parentheses x minus 13. So we have a variable in two places and we have parentheses. We have to deal with both of those before we can do backtracking. So I distribute the 5 on one side, I distribute the negative 2 on the other side. Five times 8 is 40. Negative 2 times 13 is negative 26. Subtracting negative 26 is the same as adding 26. And now I'm going to make a zero pair. The zero pair is created to eliminate the negative 2x. Whatever I do on one side of an equation, I have to do on the other to keep it balanced. 5x plus 2x is equal to 7x. We now have a two-step equation, and that's the goal, is to get it to a two-step equation so that we can backtrack. There was a number, it was multiplied by 7. $40 was added to it. And it became 26. So backtracking, I'm going to subtract 40 from 26. That's going to give me a negative result. Negative 14. The opposite of multiplying by 7 is to divide by 7. When I divide a negative number by a positive number, I'm going to have a negative result. Negative 14 divided by 7 is negative 2.